All right, so please, you can just click on, I think it's recording now. Yes, okay. So the question now is, how do we denote functions? Okay. So let me explain the notation with an example. So here's an example. So as I said, our convention is that X is the input and Y, that's supposed to be the output. Okay, so that's our convention. Now, let's say we have, I think the first one of the equations we had in the exercise. So let's say we have this minus X fourth plus Y minus 2 equals to X, right? And then we said, so we need to determine whether this is a function or not. And we solve for Y. So then, solve for Y. So when you solve for Y, we have, so this is plus X power 4 here. This is plus 2 here. The same on the right side, X fourth plus 2. So then Y, anyway, so Y is X plus X fourth plus 2, right? That's what I have on the right side. Anyway, and then we said, in this case, this equation represent, so we said this equation here represent a function, okay, because each input X corresponds to exactly one output Y, right? Now, so in this case, because the X is the input and Y is the output, we say that Y is a function of X. Y is a function of X, right? Because X is your input, Y is your output. Okay, so when you have a function, then you say that the output is a function of the input. Okay, because the idea here, guys, is that the output Y depends on the input X. Okay, so for each value of X, you have exactly one value, one output Y. So in some sense, the value of the output Y depends on the value of the input X. So that's why we say Y is a function of X. So because the value of the output Y depends on the value of the output input, depends on the input, the value of the input X. Okay, and of course X and Y, they don't have to be, in general they are not the same, right? For each value of X, you have different value of Y. Okay, X and Y, they are not the same. For each value of X, you have different value of Y. And again, the idea is, so Y depends on X. For each input, you have a different input, then you have, in general, like different outputs. So Y depends on X. And because Y depends on X, we say that Y is a function of X. Okay, so the output depends on the input. So Y is a function of X, and then we write, so we write Y equal to f of X. So this f of X, this is a notation for functions. Okay, so this is this f of X here. This is a notation for functions. So when you see, guys, Y is equal to f of X, it means that Y is a function of x. Okay, so that's, so y is a function of x. So y depends on x. Of course, well, instead of the letter f, we can use another letter, for example, G or H, or so it doesn't have to be F. Okay, so we can use a different. So here, remark. So we can use a different letter. So we can use different. Instead of F. Okay, so for example, so usually we use, for example, instead of F, we can use H. So Y is, so example. Yes, that's what I'm gonna do. Thank you, Devlin. Yes. So for instance, Y is equal to G of X, or Y is equal to H of X, okay? So it doesn't, you don't have to use the letter F. It could be another letter, right? Now, for example, so in our example, we had, Y. So here in this example, as you can see, Y is equal to X plus X fourth plus 2, right? So this is my Y equal to f of x. So in this case, f of x, the function of x is this one here, x plus x fourth plus 2, right? So so in our example, we had this y equal to x plus x fourth plus I think plus 2. Yes, plus 2, right? Plus 2. So then f of x, so y is f of x, and so this function of x, f of x is equal to this x plus x fourth plus 2. Okay. So in other words, so
can you repeat that part, please? For example.
Yes, this example y equals to x plus x fourth plus 2. That was from the previous exercise. So we got this equation here, right? And all I'm saying is, so we said in this case, this equation represents a function, right? I mean, that was I think the first problem in the previous exercise. But anyway, so we solved for y. We got this y equals to x plus x fourth plus 2, and all I'm saying is that my function f of x is equal to this expression here, to the right side here, which is x plus x fourth plus 2. Okay. So for example, let me make a table here. So here's my input x, and here's my output y. And this y is supposed to be, so it's a function of x, right? Because this equation represents a function. So y is a function of x. Y is equal to f of x. Now, for example, if you say my input x is 1, what will be my output? Well, so all you have to do, so my input x is 1. My input x is 1. So all you have to do is just to replace x by 1, right? So you have to replace x here and here by 1. So my x is 1. So then y, the output y, is going to be equal to f of 1. And what will be f of 1? The x is equal to 1. So that's 1 plus 1/4 plus 2. Right? And 1 plus 2, that will be equal to 4. So then y which is f of 1. So my output y is equal to 4. Okay. You can take a different input. So let's say, for example, my input x is 3. So what will be the output y? Well, then y is equal to f of 3. So when you write y is equal to f of 3, it means that this is the output corresponding to the input x equal to 3, right? So y is equal to f of 3. All you have to do is just replace x by 3, right? My input x by 3. So this x here and x here by 3. So that will be like 3 plus 3 to the power 4 plus 2. Okay. And that will be equal to, so then my output y, that will be equal to 3 plus 3 to the power 4, that's 81, I guess, plus 2. So that's 81 plus 5, that's 86. So in this case, if my input x is 3, my output y is 86, right? Does this make sense to you guys, what I'm saying? Okay, so again, you have this equation, this is your equation, and so this right side, that will be my function f of x. That's what I denote by f of x. So if you have to evaluate your function, you give some value to x. For example, x is 1 or x is 3 or wherever. So all you have to do is just to substitute x by the value given in the problem. So for example, x could be also a negative number, right? It could be, so it could be positive, x could be negative. So then if x is if x is negative 3, negative 4, so then f of negative 4. So all you have to do, again, to substitute x by negative 4. This x here by negative 4. So that's negative 4 plus negative 4 to the power 4 and plus 2, etc. Right? So that's for the notation of functions. Is there any question, guys?
No.
All right, so here's an exercise. Excuse me?
No, I said right now it's clear.
Okay, perfect. Then here's an exercise. Okay, so, okay, evaluate, let's say, the following functions at the given values. Okay, so let's say, so first function, as I said, whenever you have a function, so which means that you can express y in terms of x. So then the expression of x will be your f of x. So first function, let's say, is, so y is equal to f of x. So when you write y is equal to f of x, it means that y is a function of x. It means that y is the input and x is supposed to be the y is the output and x is supposed to be the input. Okay, so my function f of x, in this case, let's say it's x squared minus x plus 1. All right, so all you have to do, guys, is to evaluate let's say f of 1, f of, let's say, 2. Let's just take some simple values, and f of negative 3. Okay, number 2. So again, I have some function of x, so y. So here I'm going to use a different letter. Instead of f, I'm going to use h. Okay, as I said, you don't have to use f for functions. You can use a different letter. Let's say h of x. And h of x is, let's say, square root of 1 plus x. So just be careful here, guys. Under the square root, you have 1 plus x. and there is this -2 outside the square root. Okay, so please try to evaluate. So if your input x is, let's say, 0, then what's the output? H of 0. What will be H of 3? And let's say H of 8. Okay. So I'm going to give you, let's say, 5 minutes, guys, to think about this exercise. So all you have to do is just to evaluate the functions at the given value, right? So again, this one, like f of 1 here represent the input, right? This is your input, and what you are looking for is the output corresponding to the input x equal to 1, right? That will be f of 1. So f of 1, it's the output corresponding to the input x equal to 1, right? So I'm gonna give you 5 minutes, guys.
Let me see. Our input is F1, F2, and F minus 3, right?
No, your input is 1.
Just
Okay.
one.
You see, yeah. For example, here I'm talking here. Okay. So for example, when I write 1 here between parentheses, it means that the input is 1. And when you evaluate f of 1, so this is the input, but then the whole thing, this whole thing, f of 1, that's the output. Okay. So what's between the parentheses? The 1, that's the input. But when you evaluate f of 1, that will be the output. So it's like here, same here. Like this here, what I'm saying is -3 is the input. -3 is the input, right? But then when you evaluate f of -3, this whole thing, this is your output. F of -3 is the output. Because what's between the parentheses, this is supposed to be x, and x, that's the input. X, you see this x here, that's the input. But then when you compute f of x, so when you do this f of x, that will be the output, which is y.
Okay, because for example, can you put up and we have the x minus 4, and then we go to do the output. That is why f minus 4 equal -4 plus 0, I think so.
No. So all you have to do is, for example, you have this f of 1, right? So all you have to do is to substitute x by 1. For example, this you see this x here?
Yes.
X here, just substitute x by 1.
Okay.
And then you evaluate the whole thing, and that will be your output.
Thank you.
I think there's a question in the chat. Oh, Raviul, you have the answers. Oh, yeah. Let's see. Yes, you're correct, of course. Destiny, you got 7 instead of -5. Let me see. So -3, 9. What is it? 9 plus. Yes, it's actually it's 13. Yeah, because minus minus, that will be a plus. Yes, Destiny. Yeah, it makes positive. Yes. So I for -3, I think it would be 13. Yeah. Yes, Lorden. Yeah, just be careful, guys, with the sign. Rabiul said h of 0 is -2. That's not true. Actually,
No, it's -1.
yeah, it's
I don't know.
-1. Yes, it's -1. Yes, just be careful. Yeah. Mhm. Yes, it's -1. Yes, Lord. Yes, h of v is going to be 0. Yes, Iliani, absolutely. H of 8 is going to be +1. Yes, Lord. Yes, that's correct, guys. That's very good.
Professor, I got all of them, but can we go over the -3?
Oh, yeah. I'm
Wouldn't
gonna
that
go over. Yeah, I'm gonna go over everything.
Because
Sure.
that one I'm confused. I got -9, but you guys are saying 13, so I guess that's fine.
Yes. Yeah. Sure. I'm gonna. Yeah.
That's what I got.
Yeah, Sean.
Seven.
Yeah, Sean. You are correct. Your answers are correct. All right, guys. So yeah, let me go over. The first and the second. Okay, so for number 1, so what we are saying, so we have this y, so which is a function of x, which is x squared minus x plus 1, right? So you want to evaluate f of 1. Okay, so again, what I'm saying here is that my input x is 1, right? That's what I'm saying here. This x, oops, this x here is 1, right? So my input x is 1, and I'm trying to evaluate the corresponding output y. Okay, so all you have to do, just substitute x by 1, right? My input x is 1, so there'll be 1 here, 1, and we're gonna need a 1 square minus 1, and then plus 1, right? Does this make sense to everyone? Because I know some, sorry, some of you probably have trouble with this. Okay, all right. So then, so of course, guys, be careful with the PEMDAS rule. PEMDAS rule, right? So, for example, here, first you have to evaluate the power. Like 1 square. 1 square is just 1 times 1, so it's 1 minus 1 plus 1. So here, of course, you have addition and subtraction at the same time. So what we need to do here, because of the PEMDAS rule, well, then in this case, we have to go from left to right. So it's 1 minus 1, that will be 0. So this thing here, that's 0, plus 1. This plus 1 here, right? So the answer would be +1. And so the answer here is +1. Okay, any question, guys? So PEMDAS rule, but the thing is, you have subtraction and addition at the same time. So if you have addition subtraction at the same time, what you do is you go from you go from left to right. So you do the 1 minus 1 first. So you go from left to right, right? So you do 1 minus 1 first, and then the plus 1. Okay. I mean, in PEMDAS rule, like the addition and subtraction, I mean, the A here stands for addition, of course, and the S here stands for subtraction. It doesn't mean that the addition comes before the subtraction. It's just the addition and subtraction, like they are like in the same level, right? So when we have addition and subtraction at the same time, you go from left to right. Anyway, so for next, f of 2, right? So next, we need to evaluate f of 2. So this is f. So f of 2. So this x here is going to be 2 squared. There's 2 here. So equal to, so 2 squared minus 2 plus 1, right? This is 2 squared minus 2 plus 1. So that will be, again, same thing. Power first, so 4 minus 2 plus 1. So y would be, the output y, 4 minus 2 is 2, plus 1 will be 3. Okay, so the answer here is 3. So what I am saying, guys, so what you need to understand, guys, is that if my input x is 2, my output, the corresponding output y is 3. Okay, so if my input x is 2, my output y is 3. Now, what will be next? My input x is, so f of -3. Okay, so here be careful with the negative sign. So f of -3 is y here. Okay, so what I'm saying, I have x, my input x is -3, and I'm trying to find the corresponding output. Okay, so, well, my advice for you guys, whenever you have a negative number, I use parentheses with a negative number. So I have my -3, so I'm going to use, here's my -3. Here's my -3, all right? There's a -3 square, so I'm gonna put square here, minus, there's -3 plus 1, all right? Now, -3 squared, guys, it's like, you know, it's like -3 multiplied by itself 2 times, right? So -3 times -3, that's +9, right? Negative times negative, it's positive. So this is +9, and then, as you said, there's this minus, so that will be a plus. So here is going to be a plus, +3 plus 1, and so the answer would be 13. Okay. If there's no question, then let's move to the next, the function h. So number 2. So number 2 function, the function h. So y is h of x. So y is a function of x, and it's actually equal to, I think it's 1 plus x minus minus 2. So minus 2. Right. All right. So let's evaluate first h of 0. So my input x is 0, and I'm trying to find the corresponding output y. So if my input x is 0, so just set x by 0. Well, here's 1. So we're going to keep the 1 plus x, but x is supposed to be 0. So here's my 0. And then there's this minus 2, which is outside the, it's not under the square root, right? It's outside the square root. So then this y here, which is h of 0, so it's going to be square root of, well, again, PEMDAS rule, just get careful, PEMDAS rule. So in PEMDAS rule, the P stands for parentheses, and then the E, that's the exponent, right? So the square root, it's an exponent, because it's like exponent to 1/2, right? Square root. So what's under the square root? It's 1 plus 0. So we need to do what's under the square root. So under the square root is 1 plus 0, so that's 1. So here's my square root of 1 minus 2. Now, what's the square root of 1? Well, it's just, 1 times 1 is 1. So square root of 1 is 1. So this is, so h of 0, that's square root of 1 is 1 minus 2. So then the answer is -1. All right. Next, it's h of 3. So if my input x is 3, let's see what will be the output y. So what's the output y corresponding to the input x equal to 3, right? So all you have to do, so this is 1 here plus x. So my x, substitute x by 3, so this is my 3 here, and this minus 2 outside the square root. So again, from this rule, we do what's under the square root. So it's 1 plus 3, that's 4. So that's square root of 4 minus 2. Okay, square root of 4. So then it's exponent before the subtraction, right? So square root of 4, it's 2, because 2 times 2 is 4. So square root of 4 is 2. So this is 2 minus 2. And so the answer is 0. So what I'm saying is that if my input x is 3, my output y would be 0. And finally, last one, I think it's.
Wait, hold on, Professor.
Yes, please.
How you got,
How I got.
where you have the 4, wouldn't that have been 4 times 4? I thought we had,
It's a square root, right? You are talking about this, right?
yeah.
That's the square root. So
We leave it like that? We're not doing
no. Square root of 4 is 2. You know, because 2 times 2 is 4. Then the square root of 4 is 2. It's like saying, for example, if you have a square root of 9, well, you know that 3 times 3 is 9. So then you say square root of 9 is 3. So it's like square root of 4 is like a number multiplied by.
I was doing 4 times 4. I thought like the
No.
square of 4. Okay.
No. 4 times 4, that would be 4 square.
Ah,
That's 16. 4 times 4. But the square root of 4, it's a number multiplied by itself equal to 4, and that's 2. So this is 2 because 2 times 2 is 4.
okay, thank you. That makes sense.
Mm-hmm. Safa, you have a question, I guess. You raise your hand, right?
Professor,
Yes.
but you got the square root of 4 is because you have 1 plus 3, that is 4, and because we have the square root, we have to put it inside the square root, right?
Yes. So I got the 4 because So I got the 4 because
You have 1 plus 3.
1 plus, because of this 1 plus 3. That's why I got the 4.
Okay.
Now, okay. Now next, sorry. Let me just erase this because I want to explain again. Sorry. So now I want to evaluate the square root of 4. So what I was saying is that the square root of 4. I mean, it's different from 4 square. If you have 4 square, that's 4 times 4, and that will be 16. Now, square root of 4, it's just, this is a number, when it's multiplied by itself, is equal to 4. So which number multiplied by itself is 4? That will be 2. So that's 2 times 2. So 2 times 2 is 4, right? So that means that square root of 4 is 2. Okay, so this square root of 4 is equal to this 2. Okay, and then I have the subtraction. But again, we do the square root first because, PEMDAS rule means the exponent before the subtraction. Okay, and the square root, it's an exponent. Square root, it's like exponent half. I mean, power half. Does this make sense to you? Okay, I guess yes. Is there any other question, guys? Yes, Safa. Yes. Yes.
My question was, I want to ask about H0. I don't get it. Like how we
H
get
of 0. Yeah. What's the problem with the H of 0? Where's the problem?
I mean, I didn't get it how we get one, like how.
Yeah, okay. So you see here, so you have to substitute x by 0, right? This x here. So I substitute x by 0. You see
Yeah.
that?
Uh-huh.
Okay. Now we do, so what's we evaluate what's under the square root. So what's under the square root is this 1 plus 0, right? That's why I got
Yeah.
1 here. That's why I got 1. Okay.
Yeah, I mean, like at the end for the result, how we like what we did with the square root.
Yes. And the thing is, what's this? So your question is, what's the y square root of 1 is 1?
No, I mean at the end we get one. That is
No. The answer, final answer is -1. Final answer. So you see this is this square root of 1 here. So what I'm saying is square root of 1 is 1, right? And then there's this -2. So -2 here. So 1 minus
Okay, get it.
For
1
example,
minus 2 is,
positive
sorry?
1 minus -2 is -1. Right?
Yes. You you
Because I
subtract,
have different sign.
yes.
Okay.
You subtract you subtract 2 from 1, right? Like let's say you have 1 orange and you you subtract like 2 oranges, right? So if you remove 2 oranges, then you end up with -1 orange, right? Yes, so 1 minus 2 is the -1, yes.
Thank you.
Is there any other question, guys?
No.
Okay. All right. So yeah, so we have to be careful. I mean, we're gonna do a lot of we're gonna have a lot of functions. We're gonna evaluate a lot of expressions. So yes, you need to be careful with the with the all these operations. Square root, subtraction, etc., etc. Anyway, so this is for the how we denote functions. So next, guys, as I said, there are 2 important ways to describe functions. The first way was using equations. Now, the second way, so we're going to describe functions using graphs. Okay. So we're going to use graphs to describe functions. So first question, of course, what's a graph, right? I mean, that's, I guess, the obvious question. So of course, we always assume that x, that's the input, and y is the output. So we're gonna try to answer a lot of questions here. So first question is, what's a graph? Okay, I'm gonna explain what do I mean by a graph. What's a graph? Question number 2, we're gonna try to answer is, when does a graph represent a function? This is like similar question like for for equations. When does a equation represent a function, right? So the same for graphs. So when does a graph represent a function? Okay. A third question, actually, we're going to have 4 questions in total. So third question is, how do we read graphs? And last question is, how do we graph functions? Okay, so how do we, oops, I need to get back to the black. So how do we graph functions? All right, so we're gonna try to answer all these questions. First, we're gonna start with the first question. So what's a graph? So question number one, so the answer to the question number one. So what's a graph? All right, so we're gonna have two axes. We're gonna have two axes. Okay, there's the x-axis and there's the y-axis. Okay, and again, guys, you keep in mind x is supposed to be the input and y is supposed to be the output. Okay. Now, how do we so how do we draw this axis? So the x-axis. So the x-axis is going to be, so the x-axis is going to be like a horizontal axis. So here's the x-axis. So what do I mean by the x-axis? Well, it's just your x-axis is just your number line. So you have this number line here, and so here's your x-axis. So your x-axis is supposed to be a horizontal line. So it's a number line, so you can put numbers. So let's say here's 0, 1, 2, -1. This is just a number line, -2, etc., etc., right? So on the x-axis, so if when you have 0, it means that x is equal to 0, right? So this is like here, when you have 0 on the x-axis, it means that x is 0. When you have 1 on the x-axis, it means that x is equal to 1, right? Etc., etc. So, I mean, these numbers represent the value of x, okay? Now, there's this x-axis and there's a y-axis. So the y-axis is a vertical axis. So, and actually the y-axis is gonna, actually the y-axis passes through the 0. So here's my y-axis. This is supposed to be 0. So this is your y-axis. So it's a vertical axis. And again, it's just it's a number line. So this is supposed to be 0. This is 1. This is 2, etc. -1, -2. All right. Now, what's a graph? So, okay, so we have these two axes. Now, what's a graph? A graph is just like a curve, a curve, like a twisted line. Okay, it's not like it doesn't have to be like a straight line. So a curve, what I call a curve, is just some twisted line. You take a line and you twist the line, and that will be a curve, right? So, so a graph. So a graph is just, it's a curve, is a curve. So what do I mean by curve? It's just some twisted line. It could be also a straight line, okay? Some twisted line, okay? And so this curve, or this graph, possibly represent, it's possible that this graph or this curve represents function. Okay, so you think of a graph as a twisted line, and as I said, a graph, like for the equations, is the same thing. Like for the equations, can represent a function. Okay. So next question. So that's for the graph. That's what I mean by a graph. It's just a curve with twisted line. And next, so how, so what's the next question is, so the next question is, when does a graph represent a function, right? So question number 2, so the answer to the question number 2. So when does a graph represent a function? Okay. Well, so the idea is the following. So here's some examples. So first example, so let's say you have the following graph. So I have my 2 axes, again, this is my x-axis, and this is my y, this is my y-axis. Okay, and let's say I have this curve, okay, so this curve here. Okay, so this is my graph. Okay, now question, so does this graph represent a function? Well, the idea is, so remember the rule, guys. Each input x corresponds to exactly 1 output y, right? So the thing is, so if you take an input x, let's say here's my input x, all right? So it's on the x-axis. I am on the x-axis, so I'm gonna take some value of x. So this is my input x, right? Now, what will be the corresponding output if this is my input x? Well, so what we do, guys, to find the corresponding output is, so we take, you take the vertical line passing through the input x. So I'm going to take the, you see this vertical line here passing through the input x. Okay. And so the corresponding output y, as you can see here, so here, so because you see my vertical line intersects the graph at 2 different points. This one here, right, and this one here. Okay, and so the corresponding output y. So let's say here's, let's say this x is equal to 1, for example. Okay, so then the corresponding output is, so here output y. Let's say this is equal to 2, for example, and this output y here is equal to, let's say -3, for example. Just taking examples here, okay? So you can see if my input x is 1, okay, I got 2 possible outputs, 2 and -3, right? Because, because this vertical line, this, you see this blue vertical line, it intersects the graph at 2 different points, right? And so the 2 different points, that will be the outputs y. Okay, so what we are saying here is that if input x, let's say, is 1, then the outputs, so we have 2 possible outputs. The outputs are, yeah, so then it's not a function, absolutely. Then the outputs are y is equal to 2, or, and sorry, and y equals to -3. Okay. So the idea is, so when you have a graph, okay, and so we have some input x, to find the corresponding outputs, all you have to do is to draw the vertical line passing through the input. And so the intersection with the graph, that will be your outputs y. So another example, let's say, so in this case, of course, this graph does not represent a function, right? So then the conclusion here, So the graph does not represent function. Another example, number 2. So again, you have 2 axes, horizontal axis, that's my my x-axis, that's my inputs x, and there's this vertical axis, which is the y-axis, which corresponds to the outputs, right? This is the y-axis. That's my outputs y, okay? And let's say you have this graph here, this curve here, okay? And let's just take some values here. For example, here's, let's say x is 1, here x is 2, for example. I'm just taking random examples here. X is -1, etc. X is -2, all right? So, so what I'm saying here, guys, is that so for example, if my input x is 1, so this is my input x, right? So if my input x is 1, so what will be the output y? So all we have to do is to draw this vertical line passing through x equal to 1, right? So it's going to intersect the graph at some point here, this one here, right? And so the corresponding output would be this one here. So let's say this is y equal to -2, for example, okay? So if my input x is 1, x is 1, then output y is -2. But then we have exactly one output, right? So if my input x is 1, we have exactly one output, which is -2. And I can do the same here, you know, for this x equal to 2. I'm gonna draw this vertical line here. So how many possible outputs do we have? Well, because it intersects the graph at exactly 1 point, okay, then we're gonna have exactly one output, right? The same here. Like if x is -1 here, I'm gonna draw this vertical line, and it's gonna intersect the graph at exactly 1 point, and this point would be my output y, right? And I can do the same here, etc., etc. So this point here, this one here, the corresponding y would be my output. Okay. So the idea, guys, is that, so in this case, like in this example, this graph represents a function, because if you take any vertical line, it's going to intersect the graph at exactly 1 point, right? And that point would be my output. Okay, so this example here, so each, as you can see, so each vertical line intersect the graph at exactly 1 point, exactly 1 point, and that point would be my output y. That would be my output y. Okay. So this graph, in this case, so this graph represent a function. Right. So in general, guys, so when you have a graph and you want to determine whether the graph is represent a function or not, so what we can do is we can use what we call the vertical line test. So the vertical line test, so what's a vertical line test? So a vertical line can intersect the graph at no more than 1 point. So because if a vertical line intersects the graph at more than 1 point, so if it intersects the graph at 2 points, let's say, it means that you're going to have two possible outputs, right? So to determine whether a graph represents a function, we use this vertical line test. Whether a graph represents a function, we use the vertical line test. So what does it say in the vertical line test? So if vertical line test. So if each vertical line intersect the graph, so if every vertical line intersect the graph at no more than 1 point, then the graph represents a function. Sorry, every intersect the graph at no more than 1 point, okay? So no more than 1 point, guys, means it's no point or 1 point. So both are okay. So if it intersect the graph at no more than 1 point, then the graph represents the function. Then the graph represents a function. Okay. So for example, so here's more examples, and then I'm going to give you exercise, guys. So this is a very simple test, right? You take vertical lines. So if all your vertical lines intersect the graph at no more than 1 point, then the graph represents a function, okay? That's a very simple test. So let's say you have this 2 axes here, there's 2 axes here, second example, right? And so for number 1, let's say the graph is this, the graph is this one here. And for number 2, so let's say is this, the graph is this one here, okay? So I have my 2 graphs. Of course, this is supposed to be the horizontal. This is supposed to be the x-axis, the vertical axis, that's the y-axis. This is x, here's supposed to be y. X is the input, y is the output, okay? So for first example, guys, do you think it's do you think the graph represents a function or not? Yes, because, well, you take vertical lines, okay? All your vertical lines, they can intersect the graph at no more than 1 point, right? So here's the 1 point here, 1 point here, 1 point here, etc. Okay? So by this vertical line test, so this graph is a function. Graph is a function. So number 1, it's a function, right? Number 2, well, if you take, let's say, if you take this vertical line, well, this is vertical line here, it's okay. Intersect the graph at one point, that's okay. But if you take like a vertical line, like here in the middle, somewhere here, right? So it's gonna intersect the graph like, you know, at like 3 points. Okay. And well, it's 3 points, of course, that's more than 1 point, right? So it's more than 1 point, then it's not. If you have just one vertical line which intersect the graph at more than 1 point, then it's not. Yes, Gordon. So this is not. So the second graph is not a function, right? So this is a very simple test, right? So this is number 2. This is the second is not, yes. So this graph is not a function. So here's an exercise, guys. All you have to say, you have to determine whether the graph is a function or not. Okay, so exercise. So you have to determine whether the graph represents it's a function. All right, so let's see. Number 1, 1, let's say 2, let's have the 3 different graphs, okay? As usual, so we have my 2 axes, my x, my y axis, my x axis, my y axis. All right, and so here's the graph. So first, let's see. Okay, so for number 1, I'm going to take this graph. For number 1, it was green. Okay, so here's my graph. Number 1. Number 2. So the graph is the following. It's number 2, and number 3. So the graph is, let's see. Yes, I have this. Okay. So I'm going to give you, let's say 1-2 minutes, guys, to think about this exercise. So all I have to say, all you have to do is to use this vertical line test, right? Yes, Rabiul. Yes, guys, you're correct. Yeah, I think it's this is not really complicated, right? So for number 1, if you take any, vertical line, is going to intersect the graph at exactly, 1 point here. If you take this one here, is going to intersect at this point, et cetera, et cetera. So this is a function. So the graph is a function here. For number 2, well, here, if you take this vertical line, is going to intersect the graph at more than 1 point. It's actually intersect the graph at 2 points. So this graph is not a function. And even worse, so here, if you take this vertical line, it's going to intersect the graph at more than actually 2. It's like 1, 2, 3, and 4 points, right? But it doesn't matter, right? Either 2 points or 4. If it's more than 1, okay, if it's more than 1 point, then it's not, okay, then it's not a function. Then the graph does not represent a function, okay? So this is not a function. For number 3, well, here on the left, if you take this line here, well, it's going to intersect the graph at 1 point, so that's good. But then on the right side here, if you take this vertical line, right, it's going to intersect the graph at 2 different points. 2 different points means 2 different outputs. So in this case, this is not a function. Okay, again, so we are using this vertical line test. So in the test, guys, or in the test, or in the exam, or in the homework, so whenever I have to compound function, no, not really, actually. No. No, it's not actually. So guys, in the test or in the exam, if you have a graph and you need to say whether the graph is a function or not, all you have to use is this vertical line test, okay? Nothing else. Is there any question, guys, about this exercise? Nope. Okay. Then next, so the next question we're gonna try to. Why is there a break? Where? You mean in the in number 3, right? I guess, Lauren. Yeah, I mean, this is just it's a random. This is a random graph. It's not. I mean, the two components are not connected. But anyway, it's just some, it's just some graph. It's a very random graph. It's but anyway, it's not a function, right? So the next question we're gonna try to answer. Remember, guys, we had a couple of questions we're gonna try to answer. Where are they? So what's a graph? We just answered, we said the graph is just a curve, some twisted line. When does a graph represent a function? Well, we can use this vertical line test. Now, next, how do we read graphs? Okay, so this is really important, right? So how do we read graphs? It means, so if your graph represents a function, so how can we find the outputs y? So, the answer to the question number 3. So the question is, how do we read graph of functions? And now I'm going to suppose that I have the graph of function, right? Which means that the graph passes the vertical line test, and we're going to see how we read the graph of functions. So here's an example. So we have, so this is my x-axis. So it's a number line. So let's say we have, I'm gonna need 0, I'm gonna need 1, 2, 3, and I'm gonna need, probably I can use more space here, sorry. So I'm gonna need, so 1 here, say 2, 3, and here it's -1. So it's -2. Now the y-axis, let's say this is my y-axis. Okay. So this is 0. So let's say this is 1. Here's 2 and -1. Okay. So let's say we have this following graph. Let's see. And then here. And then, okay. So let's say this is the graph. This is my graph. Okay. So first question, guys. So first, I'm going to try to explain the difference. There's this empty circles, guys, right? So when you have this empty circle, okay, and a graph, okay, then it means that this point, so this point, so the point actually do not belong to the graph. Okay, so whenever you have this empty circle, it means that that point, actually that point doesn't belong to the graph. Okay. It's not included in the graph, okay? Not included. That's not included in the graph. Okay. Now, so I'm gonna try to read this graph. So for example, let's say you wanna find, so this is, let's say, graph of my function f, graph of a function, right? Graph of f of x. Okay. Now, let's say you wanna find, so we wanna find f of, so find, I'm gonna try to find f of -2, f of -1, f of 0, f of 1, f of 2, okay, f of 2, and then f of 3. Right. So let's start with f of -2. So what does it mean, f of -2? Well, first, it means that my input x is -2, right? So f of -2 means that x is -2, okay? And what I'm trying to do here, I'm trying to find, yes, Gordon, it's gonna be +1. So, what I'm trying to do now, guys, is I'm trying to find the corresponding output to the input x equal to -2, right? So I'm trying to find output y corresponding to the input x equal to -2. So x is equal to -2. So I have to go to my x-axis. So the x-axis is the horizontal axis. So x is equal to -2 is here, right? This is my x. This is x equal to -2, right? So this is x equal to -2. Now, I want to find the corresponding output. My input x is -2. I want to find the corresponding output. So how do you find the corresponding output? Again, all you have to do is to draw this vertical line, right? Passing through the -2, because my input x is -2, right? And so the intersection with the graph would be this point, right? So what's the corresponding output to this point? Well, the corresponding output, well, we have to draw this horizontal line. So this horizontal line here intersect the y-axis at +1, right? You see here, guys, this is +1. So this is the y-axis. So y, the output y is 1. Okay. So what we are saying here, guys, is that I'm gonna probably erase this here. So if x is -2, then f of -2, right? So this is, so f of -2 is going to be equal to +1. Okay.
Professor, I have a question.
Yes. Yes. Please. Yes.
We are following the last step that we were doing before. Like, for example, when you put the 1, it's always 1.
Where?
For example, because you select -1 and 1. No, -2 and 1.
Oh yeah. So you mean here, right?
All right, here. Uh-huh.
Yeah. So what I'm trying to do here. So the question was to, for example, was to
Why you
find.
select 1 and not 2?
Yeah, I'm gonna. Yeah. So I'm trying to find f of -2, right? So what I'm saying here, so this graph supposed to represent the graph of the function f. Now, the -2, that's my x. This -2 between the parentheses, that's my x. That's my input x, right? You agree with that?
Yes, input.
Okay, so the input is -2. Now, f of -2, that's supposed to be this is my output. So I'm trying to find the output corresponding to the input x -2. So what you do is you go to the input x is -2, which is this one, right? This point here. This is x is -2, right?
Yes.
Because the x axis, you see here, x axis, that's the horizontal axis.
Yes.
Okay. So what I did is I draw the vertical line. You see this blue vertical line here?
Yes.
Passing through -2.
Mhm.
Okay, it passes through the input x -2. Now, this blue line intersects the graph, the red graph, at this point here, right? This is my intersection with the graph. That's where my vertical line intersects the graph, right? At this point. Is that okay?
Yes.
Okay. Now, I need to find the corresponding output. So what I do is I draw the horizontal line passing through that point, right? This is my point, right? This is where I have the intersection, right? So to find the output, I have to draw the
Mark it down.
vertical line. Yeah, the horizontal line. This one, the green line. You see the green line?
Uh-huh.
So the green line intersect the y-axis here, and that's y equal to 1, right? This is where y is 1 here. This point here, that's
Mhm.
where y is 1.
Okay.
That's the
Mm,
vertical axis, right?
Wouldn't it
Y-axis. Yes,
wouldn't
please.
it be one at like at -½ too? Because it's touching the line there too.
Which line? The red?
Yeah.
No, the red. The red. The graph. That's the graph of the function f. So if you want to find the output, you have to go to the. You have to intersect your y-axis, the vertical axis. This one here. You see this axis here?
Yeah.
That represents the outputs y. Okay, so you start from your intersection. This is my intersection, right? This is my intersection, and I draw this horizontal line, and it intersect this y-axis at this point, exactly here. You need to intersect the y-axis, the vertical axis, to find the output y. Does this make sense to you? So here the answer would be +1, because again, let me explain again. I know this is for some of you guys, I know this is not obvious. So my input x is -2. Here's my -2. I draw first this vertical line, intersect the graph at just exactly 1 point, which is this green point here. And now I have to draw this horizontal line, and I have to go to the y-axis. So when you go to the y-axis, you have here this intersection, which is that represent the value y equal to 1. So that's why the answer is 1 here. F of -2 is 1. So for example, next, okay, let me do the next. And
But I'm
let's see.
saying, wouldn't it
Yes.
be like if you did f of
Neg-
-½, wouldn't it be 1 too?
F of negative. Oh yes, yes,
Okay.
yes, yeah, absolutely. So yeah, I'm gonna do more examples. Yes. Mhm. Yeah, f of -1/2 would be 2. Yes.
No, it would be 1.
-1. Yes, it would be 1. Sorry, it would be 1. Let me do the next value, which is, so I have f of -2. So the next, I'm doing just whole numbers because I know it's easier, I guess. But the next, let's say it's f of, what will be f of -1? So again, my input x is -1.
It'd be 0.
It'll be 0. So first, okay, let me explain this. So first, here's my x equal to -1. Right now, I'm supposed to draw this vertical line passing through this -1, right? And so where does it intersect the graph, the red graph? Well, it's going to intersect the red graph at the same place here, right? This right here, right? The same point. Okay, and now I'm supposed to like draw a horizontal line passing through that point and going to the y-axis. So if you draw this horizontal line passing through this point, going to the y-axis, you're gonna get y equal to 0, right? So then f of -1 is 0. Okay. Now, next, what will be f of 0? No. So this is tricky, kind of tricky. So, what will be f of 0?
2.
That's not true, actually.
Oh, no way, because you said that
So,
doesn't count.
yeah, it doesn't count. Yes. So, okay. So, guys, so f of 0. Well, so here's my input. Sorry. So here's my input x equal to 0. This is where x is 0, right? And now, again, I'm supposed to draw this line here, this vertical line passing through 0. So now, where does it intersect the graph? Well, in some sense, it's supposed to intersect the graph here, right? At this point here, right? But the thing is, this point, because it's an empty circle, right? It's not included in the graph, the empty circle. So this point here, it doesn't belong to the graph, which means that, so there's no intersection actually with the graph. So when you have this, when you have this blue line here, this this vertical line here, this blue line, it actually doesn't intersect the graph, because this point, this one here, it's empty circle, so it's not included in the graph. So which means that there is no intersection, because that point, doesn't count, so it's not included in the graph. Okay, whenever we have an empty circle, it's not included. So there's no intersection here, because it's not that point is not included in the red graph. So this is no intersection. There's no, sorry. So there's no intersection. So if there's no intersection, it means that if the input x is 0, then there is no output. So the answer here is there's no output. So the answer is undefined if there's no output. Okay. What will be f of 2? Okay, so let's say you want to find f of +2. Okay, so f of +2 means that x, my input x, is equal to 2, right? +2. So I'm gonna go to x equal to +2. So here's my x is equal to +2, right? Now I'm supposed to draw a vertical line passing through this input x equal to -2. So my question for you guys, where does this blue line intercept the red graph?
It's undefined.
Well, it's undefined here, you're right, but still, you have an intersection
Negative
here.
half, or
Oh, I didn't see
Yeah,
that one.
at that
-3/4.
point. -1, actually. I'm sorry.
Okay.
Here's this is supposed to be like -1. So this is actually kind of tricky. So yeah, so here we don't have an intersection. So there's no intersection here, because that point is not, this empty circle is not included in the graph, but we still have intersection here, right? At this point. And so now what will be the corresponding output? So we draw this a horizontal line, and so the corresponding output is y equals to -1. So the answer here, it's not undefined, that would be incorrect. So the answer is actually -1. This is -1. Okay. Any questions, guys? So let's have a similar exercise, similar problem, okay?
I have one question.
Yes, please.
So on the +3, what would that be, like the answer? Like that
Yeah, so what's the answer? Yeah, what will be f of positive phi? Sorry, I forgot about f positive phi. What will be the answer? What do you
I
think
don't
the
know.
answer?
Maybe like 0 or maybe negative.
Okay, so how do you find the f of positive phi? What do you do to find the f of positive phi?
I just put a vertical line through
Yes,
because of the
absolutely.
red line.
Yes. So absolutely. So this is your input x negative sorry, positive phi. And so you, as you said, you draw this vertical line here passing through this positive phi, right? Now, where does it intersect the graph? Well, it intersect the graph here, right? Because the graph is supposed to go like from here to here, right? So we have intersection at the same place, right? The same point, right? Now, to find the output, you use a horizontal line, and you go to the y-axis. So when you go to the y-axis, well, the y would be 0.
Okay,
You see?
thank you.
Mhm. So then f of positive phi would be 0. Okay. I know this is kind of tricky, especially with this like empty circles. So let's have a similar exercise problem. So exercise. I know this is really important. I mean, you need to know how to find the values of your function f. So I'm gonna draw a graph here. This is my x. I'm gonna need 0. I'm gonna need 1. I'm gonna need 2. I'm gonna need -1, -2. And here, my y-axis, I'm gonna need probably +1, and let's see, just -1 here in the bottom. All right, so okay, let's see. So okay, so this is my f of x. This is the graph of f of x. Okay, so what you need to do, guys, you need to find, I can probably do this like here. All right, so what you need to do, guys, is you need to find f of -2, f of -1, f of 0, f of +1, and then f of +2. Okay. So let's say you have 5-10 minutes to find these values of the function f. All right. I'm gonna change here my graph a little bit. So I'm gonna put a circle here. Another circle. Yes, Rabiul, f of -1 is +1. Yes. Sorry, f of -2 is +1. Yes. So again, guys, just to remind you, so this is empty circle. This is not included in the graph. F of 0. Yes, Rabiu. F of 0 is
I'm
gonna be
confused in the last one.
the last one.
Positive
Mhm.
2. Equal
Yes.
positive 2 with negative 1, or it could be nothing, like undefined.
Yeah. So it's gonna be undefined, right? Because because if you take the vertical line passing through the positive 2, so actually it doesn't intersect the graph because you're gonna have these two empty circles, right? So they don't belong to the graph. Okay, so there'll be no intersection with the graph. So yeah, for f of positive 2, the answer will be undefined.
Undefined. Okay.
Yeah.
Thank you so much.
Sure. Are there questions on the chat? I'm sorry, guys, because okay. Oh, yeah, you have the answers here. So okay, let me see. So yeah, Rabiul, actually, f of 0. Remember, when you have a function and you have an input, so you always have like exactly one answer. You cannot have like two answers. So for example, f of 0, you cannot say it's either 1 or undefined. You have to choose, because for each input, you have exactly one answer, one output. So you have to choose either it's 1 or undefined. Okay. And between 1 and undefined, it will be 1, because it means that you have an intersection. And so the answer would be 1. For I guess for that's f of 0. Yes. Yeah, the f of 1 is 0. Yeah, everything else is correct. Lorden, let's see. f of 0, you're saying is 0. I don't. It's not. Oh yeah, f of 0 is 1. Yes. Okay, you correct your answer. Yes, absolutely. Yeah, correct. So I'm gonna just give you more time, 1 or 2 minutes, guys, and then. So next, I guess, did we answer all the questions? So what's a graph? When does a graph represent a function? How do we read graphs? Oh yeah, last question would be the how do we graph functions? Sean, let me see. Sean, you said f of yes. Yes, Sean. Very good. Yes, that's
Thank you.
correct. Mhm.
Professor,
Yes, please.
f of 2 for me look like a 1, positive 1 going up.
Nope, because you take f. So here's the 2, right? And let's say here's your vertical line, right? You're saying f of 2 would be positive 1, right? But you see, the thing is, because this point doesn't belong to the graph, so here there's no intersection here. There's no intersection with the graph, so we cannot say that will be that's the output, because there's no intersection. So to have an output, you have to intersect the graph, right?
Oh, now I see it, because I was going more to the left. It's okay. Now I see
no.
what you mean.
So
All right, thank you.
yeah, your vertical line must intersect the graph. If there's no intersection with the graph, it doesn't count. It's not.
All right.
It's not an output. Mhm.
Thank,
Mhm. Let me just erase this here. Are you done, guys? One more minute, probably. But anyway, I mean, we have like, how much is? Let's see what. Oh yeah, we have like. We're supposed to finish at 10, right? What time? Let's see. 9:55 or 10? I don't know. I forgot.
9:55.
Okay, sorry. I wasn't sure. Okay, 9:55. Okay, so we have like 7 minutes. Okay. All right. Okay, so probably 7 minutes would be just like enough time to go over this exercise, unless someone needs like 1 more minute. Probably not. Okay. Okay. So yeah. Okay. So let's do this. For f of -2, guys. So here's my -2. I'm gonna draw my vertical line. You need intersection. If your vertical line doesn't intersect the graph, then you don't have an output, right? So, well, I do have an intersection here, right? And the corresponding output, the y, would be +1, right? This is your y-axis. That's where you find your output, right? So you have to go to the y-axis. And so on the y-axis, so this point corresponds to the output y equal to 1. So the answer here is +1. Please, guys, feel free to ask questions, okay? If you don't understand why f of -2 is +1, now it's the time to ask the question, okay? Because later is gonna be it's gonna be late. All right, so what about f of -1? Well, f of -1, I'm gonna 0, yes, because I'm gonna draw my vertical line here, but so an intersection of the graph, that will be the same point. So it would be this, right? Which is like the same as the x equal to -1. Now I want to find the corresponding output. Then I have to draw this horizontal line. I have to go to the y-axis. And if you go to the y-axis, then y would be 0. So the answer is 0. Next, f of 0. So here's my vertical line. So as you can see, guys, here there's no intersection, right? Because it's an empty circle, so it's not included in the graph, so it doesn't count. So there's no intersection there. So I don't really care about it, right? Because it's not included. There's no intersection. However, on the other side, I mean, at 1 here, we do have an intersection here, right? There's an intersection here. Now, I need to go to the y-axis, right? But this point here actually lies on the y-axis, right? It's on the y-axis, right? So the corresponding output y would be +1. So the answer here is +1, right? Next, f of +1. Again, the same thing. I have my my blue line, my vertical blue line passing through +1. The intersection with the graph is this point, is the same point. And now if you go to I have to go to the y-axis using the horizontal line. You go to the y-axis, you get 0. So the answer here is 0. Now, finally, last one, kind of tricky, the f of +2. So if you draw your vertical line passing through the +2, well, you don't have an intersection. Neither, I mean, here, right? At this point here, it doesn't belong to the graph. Well, nor here, right? So it's this point also doesn't belong to the graph. Okay, so we don't have an intersection of the graph at +2. So which means that if my input X is positive 2, there's no output. So then this is undefined. And again, guys, your answer, because this is a function, then the answer, you're supposed to have just exactly one answer. You cannot have like two possible answers, right? Because this is a function. For each input X, you have exactly one output Y. So you have exactly one answer. It's either undefined or it's some number. The answer cannot be both, right? Like for f of 0, you cannot say, if you say f of 0 is positive 1 or undefined, that's not correct, okay? Because you have the answer must be unique, right? You have exactly one answer. All right, guys. So that's how we read the graphs, right? So next question, and the last, next and last question we're gonna need to answer is, how do we graph functions? Well, we have like 2 minutes to answer the question, so probably it's not enough, right? So probably I'm gonna stop here. I mean, for first lectures, probably is too much. But so I'm gonna stop here, guys. I'm gonna upload the recording on YouTube. I will send you the link, and tomorrow I will post the first homework on CUNY Blackboard. All right, and so for the first homework, homework is gonna be due on Friday, Friday night. Okay, everyone. Thank you, everyone, and so I guess I'm gonna stop recording, and I will see you tomorrow, same time at 6 p.m. Good night, everyone.
Thank you,
Good night,
Professor.
Professor. Thank you.
Thank you.
Professor,
Good
bye.
night.
Care.